In this video, we're diving into the world of Python's functional programming tools: map, filter, and reduce. Functional programming is a paradigm where functions are treated as first-class citizens. Computation is viewed as the evaluation of mathematical functions. Python offers built-in functions like map, filter, and reduce to make functional programming easier. Let's start with the map function. The map function applies a given function to each item in an iterable, like a list, and returns a map object, which is an iterator. The syntax is straightforward. Map takes a function and one or more iterables as arguments. Here is a basic example. We define a function called square that returns the square of a number. We have a list of numbers from 1 to 5. We use the map function to apply the square function to each number in the numbers list. The result is converted into a list. So the final result is a list of squared values. Now let's see how we can use Lambda functions with map for more concise operations. Lambda functions, also known as anonymous functions, are small, one-line functions that can be very useful in functional programming. Using Lambda with map is ideal for simple transformations that don't need a separate named function. Here are a couple of examples. In the first example, we are squaring numbers using a Lambda function. Instead of defining a separate square function like before, we use a Lambda function right inside the map function. The result is the same, a list of squared values. In the second example, we convert Celsius temperatures to Fahrenheit using a Lambda function. The Lambda function performs the conversion, and map applies this to each temperature in the Celsius list. The result is a list of temperatures in Fahrenheit. One of the powerful features of the map function is its ability to work with multiple iterables. The map function can take multiple iterables as arguments. When you provide multiple iterables, the function you pass to map must accept as many arguments as there are iterables. Elements from all iterables are processed in parallel until the shortest iterable is exhausted. Here is an example with multiple iterables. Let's define a function called @_multiply, which takes 3 arguments x, y, and z. This function returns x plus y times z. We have 3 separate lists: list 1, list 2, and list 3. We use map with the @_multiply function and all 3 lists. The map function applies @_multiply to corresponding elements from each list. The result is a list where each element is the result of the @_multiply function applied to the corresponding elements from list 1, list 2, and list 3. Now let's explore the filter function. The filter function constructs an iterator from elements of an iterable, for which a function returns true. The syntax for filter is filter, then the function and the iterable. Unlike map, filter returns only the elements that satisfy a condition. Here's a basic example. We define a function called is_even, which checks if a number is even. We have a list of numbers from 1 to 10. We use the filter function with the is_even function to filter out odd numbers. The result is a list containing only the even numbers from the original list. Just like with map, Lambda functions work very well with filter for writing concise filtering operations. The function provided to filter should return true for values you want to keep and false for values you want to filter out. Here are a couple of examples. In the first example, we are filtering numbers greater than 5. We use a Lambda function to check if each number is greater than 5 and filter keeps only those numbers. The result is a list of numbers that are greater than 5. In the second example, we are filtering strings with a length greater than 3. We use a Lambda function to check the length of each word. Filter then keeps only the words that have more than 3 characters. The result is a list of strings with more than 3 characters. One interesting use case of the filter function is when you pass none as the function. If none is used as the first argument to filter, the function simply returns the items that are truthy. This is useful for filtering out none values, empty strings, zeros, empty collections, and other falsy values. Here are a couple of examples. In the first example, we filter out falsy values from a mixed list of data. We pass none as the function to filter, and the result contains only the truthy values, such as non-zero numbers, non-empty strings, and non-empty lists. In the second example, we are filtering out none values from a list of data. Again, we pass none as the function to filter, and the result contains only the valid data, in this case the strings apple, banana, and cherry. Now let's move on to the reduce function. The reduce function applies a function of two arguments cumulatively to the items of a sequence, reducing the sequence to a single value. In Python, reduce is not a built-in function, but it is found in the functools module. The syntax is reduce, then the function, the iterable, and an optional initializer. Here is a basic example. We first import reduce from the functools module. We define a function called add, which takes two numbers and returns their sum. We have a list of numbers to sum. We use reduce with the add function and the numbers list. The result is the sum of all the numbers in the list. Let's look at some more advanced features of the reduce function. Lambda functions can simplify reduce operations for concise one-line code. The optional initializer argument sets the starting value for the accumulation. If provided, it becomes the first value in the reduction process. Here are some examples. In the first example, we use a lambda function with reduce to multiply numbers. The lambda function takes two arguments x and y and returns their product. The result is the product of all numbers in the list. In the second example, we use an initial value of 10. The lambda function is the same, adding two numbers. The result is the sum of all the numbers in the list plus the initial value of 10. Finally, let's look at what happens when we use reduce with an empty list. If the list is empty, reduce requires an initial value. The result is simply the initial value itself. Combining these functional tools can create a very powerful data processing pipeline. The typical order is filter, map, and then reduce. First, you filter out any unwanted elements. Then you map to transform each element. Finally, you reduce to combine everything into a single result. Here is an example of combining all three functions. We start with a list of numbers. First, we filter the list to keep only the even numbers. Then we map the filtered list to square each number. Finally, we reduce the squared numbers to get their sum. The result is the sum of the squares of all the even numbers in the original list. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.